All right, so today we're going to be talking about limiting reactants and the calculations that go along with it. So when we're talking about limiting reactants, we're talking about the reactant that limits how much is produced. So here's an analogy for you guys. Think about when you guys are making hot dogs, right? You're going to have the buns come in packages of 6. The actual hot dogs come in packages of 8. So we can have 8 actual dogs. That's 8 dogs, right? We can have 6 buns, and that's how we have to buy it at the grocery store. So if I just want to get one thing of buns and one thing of, the dogs, how many hot dog sandwiches can I make? I can only make 6 total hot dog sandwiches, okay? That's 6 total hot dogs. So what gets used up by the reaction that I use all of, the buns, is going to be my limiting reactant. So that's going to be our buns. The dogs, we've got 2 extra meat hot dogs left over. Those are called the excess reactant. Excess, extra things that's left over. Okay, so that's going to be the actual dogs. All right, so that's just an idea, get you guys thinking about what a limiting reactant is. We're going to do the same thing when we're talking about chemicals. What gets fully used up by the reaction, and then what do we have leftovers with once we've had all of our, elements recombine into different compounds. All right, so let's do a couple of examples together. Okay. First example, if 5 grams of iron reacts with 4 grams of oxygen, how much rust can be formed? So you're going to label each as the limiting and the excess reactant after we decide. So your limiting and excess reactant are going to be either iron or oxygen. So what we're going to start with our given of each. So we're going to start with 5 grams of iron, and we're going to see how much we can produce. So we're going from grams of iron to grams of Fe2O3. So the next thing that we're going to do is we're going to go from grams into our, moles. Remember your mole map? We've got moles, we've got grams over here, we've got particles. Okay, so from grams to moles, that's our molar mass from the periodic table. And then this is going to be Avogadro's number, okay, 6.02. So we're going from grams to moles. We're going to use our molar mass. The molar mass of iron, 55.85, gets to moles. Next thing we're going to be doing is we're going to be using our mole ratio. So if you guys look at our equation here, we have 4 moles of iron for every 2 moles of rust. Okay, so it's a 4:2 ratio. So we get this number from the coefficients of our balanced equation. So you have to make sure you have a balanced equation. All right. Then what we do, we have our moles of rust. So we're going to go back to grams of rust. Okay, so we're going to add up our molar mass of rust, which is 159.7. So that's going to be 2 irons, 3 oxygens to get that number. So this number comes from 2 times 55.85 plus 3 times 16 gives us 159.7. Okay, that's how we get that molar mass. All right, and then what we're going to do, multiply across the top, divide by the bottom, throw it in your calculator, and you should get 7.15 grams of Fe2O3 of rust. Okay, so that's a gram to gram. Now what we're going to do is we're going to do the same process, but we're starting with our 4 grams of oxygen. So you'll see how they match up. So we start with 4 grams of oxygen. Remember, it's O2 because it's diatomic. And we're going to go from that into our moles, so 32 grams of oxygen to 1 mole. Then again, look at our equation. We've got, I'm going to do a box around it this time, 3 moles of oxygen for every 2 moles of rust. So that's our mole ratio we're going to use. Okay, 3 moles of oxygen to 2 moles of rust. And then once we're in moles of rust, our last set of parentheses will actually be the same. We have the same molar mass, okay, 159.7. So we're going to put that in there. And we finally got to grams of our rust. So if you guys look, you should be able to cross out your units. Grams of oxygen cancels out grams of oxygen. Moles of oxygen cancels out moles of oxygen. Moles of rust cancel out moles of rust, and you're left over with grams of rust. Okay? Put it in your calculator. 4 times 2 times 159.5 divided by 32 divided by 3. Put it in your calculator. You should get 13.31 grams of rust. Okay? So now we need to decide, once we've done this math for both of them, which one is our limiting reactant. Well, 5 grams of iron can produce about 7 grams of rust. 4 grams of oxygen can produce 13. So it looks like if we have 5 grams of iron, 4 grams of oxygen, I'm going to end up producing less rust right here with my 5 grams of iron. So this is going to be my limiting reactant, okay? So this is my limiting reactant. Okay, iron is my limiting reactant. So oxygen is thus my excess reactant. My excess reactant, okay? So you want to label them limiting reactant, excess reactant. All right, let's try another one. All right, so for this one, I'm going to have you guys do the second part. I'm going to do the first part for you. Okay, so I'll do the fluorine, and I want you guys to try the NH3. So 22.4 grams of fluorine reacts with 15.7 grams of NH3. How much HF can be formed? So you're going to label each as limiting or excess reactant. All right, so what I've given you right here is I've given you a balanced equation. So put a box around it, put it at the top of the page. Make sure you know that you can always come back to that. Okay, so what I'm going to start with is 22.4 grams of fluorine, and then I'm going to use my molar mass. I know 19.0 times 2 is going to be 38.0 grams per mole, and that's going to be what I use for my molar mass of fluorine. Okay, now what I want to do, oh, this should actually say to moles of not O2 but F2, I apologize. Okay, you should have 38 grams of F2 to 1 mole of F2. So next what I'm going to do is I'm going to compare fluorine to hydrofluoric acid. Okay, so I have 5 moles of fluorine to 6 moles of HF. Okay, 5 to 6. Okay, so put that in there. And then I'm going to calculate my molar mass of HF, so I can go from moles of HF to grams of HF. So I've got H plus F, so that's 1.01. Plus 19, so it should be 20.01. Okay? And you guys can see, you can do your molar mass calculations on the side margin, somewhere where you can see it. All right? So you're going to do that, 20.01 grams of HF over 1 mole of HF. And you'll notice that my units are going to cancel out. Grams of HF, grams of HF. Moles of F2, moles of F2. 6 moles of HF, moles of HF. And you're left over with grams of HF. Put this in your calculator, and you should get 14.15 grams of HF are being produced. So now what I would like you to do is I would like you to set up 15.7 grams of NH3, okay, over 1. And I would like you to convert this all the way to grams of HF. So you're going to use this unit conversion and this unit conversion to help you. Okay, so convert this grams to grams of HF, and then choose which one produces less. That's going to be your limiting reactant. The one that produces more, there's going to be extra of. Okay, so that's going to be your excess reactant. All right, finish that out, and we'll go over it tomorrow in class. Nice.